Saxon Algebra 1, Lesson 113. Today we're going to talk about variations. There are two kinds. There's direct variations and there's inverse variations. We're going to talk about those. We'll explain the difference. But this is a topic that we're going to come back to next year and elaborate on. So this will just give you kind of a running start at understanding them so that next year when you see them again, you'll be like, oh, okay, I remember this. All right, here's the best way I can explain direct variations. Have you ever, excuse me. Have you ever watched toddlers play? Like maybe kids at a play group, or maybe you've babysat like at your nursery at your church or something before. Here's what happens. When one kid comes in the room, a toddler, a room that's set up for play, right, has a bunch of toys in it. If one child comes in the room, they don't just get out one toy to play with. They get out like 5 toys to play with, right? There's one child, 1, 2, 3, 4, 5. Okay, this is the number of toddlers. And this is the number of toys. When the next one child comes in the room, they get out 5 more toys. This is, and just imagine if we kept adding toddlers, the toys would go way up, right? This is what we're calling a direct variation. As one thing increases, the other thing increases by a different magnitude. In this one, I assumed that one kid would get out 5 toys. That was my assumption. But we can write this as the number of toddlers equals the number of toys times a constant that we call K. Right? And this can be simplified as A equals K times B. We can change the A and the B. In this case, it would be toddlers and toys, right? I've got the constant in the opposite place, but you can put it at first. We can change that simple equation to match to whatever our story is, right? If it was the number of pigs varied directly with the number of mud puddles, I don't know, I'm just making that up, then we could quickly change this to pigs and mud puddles, right? Sometimes the problems that we work are going to come from a scientific point of view, like physics is a really popular one. Other times they will be just everyday life things. Most students find the everyday life ones to be pretty simple, like toddlers and toys. And that's cool. So we're going to do 2 of these, and we're going to do the everyday simple one first. Actually, there's 3 of them. So we're going to start with example 113.2 because that's the non-sciencey one. We're going to use this formula, which looks a little vague at this point, but it's okay. We'll figure it out. The distance traversed by a car traveling at a constant speed is directly proportional. There's the words we're looking for. As soon as we hear directly proportional, we know we can use our formula. Okay? It's directly proportional to the time spent traveling. Well, that makes sense, right? The distance is proportional to the amount of time you've driven your car. I mean, unless you're in a traffic jam. If a car okay, so we can fix it. Distance is directly proportional to the time. Here's the thing. Just read yourself the sentence the way it's written. The distance traversed by a car traveling at a constant speed, blah, 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 is directly proportional, that kicks me into my formula, to the time spent traveling. So I put them in the same order. I put the letters in the same order in the problem as they appear in the sentence. Distance is directly proportional to the time. So that's why I put the D here and the T there. Don't overthink it. Now, it's always, once we identify this, then we have a two-step situation. In the first one, we solve for K. So John is going to give us a value for D and a value for T, and we're going to use those to solve for K. Let's see how that works. If the car goes 75 kilometers, that's a distance, in 5 hours, that's a time. I'm going to pause reading the problem right there because we can take this information and solve for K. It tells us that 75 equals K times 5. K is what we want by itself, so we divide away the 5, and we find that K equals 15, right? So 15 is not a distance or a time. It's a special number that relates distance and time. We know it has to do with speed, but we don't need to know that for this problem. Just like over here, I said that there was a magic relationship between one kid and 5 toys. I made that up, but that would have been that would have driven our K over here. Okay, so we've solved for K. Now the second part is we're going to solve for the mystery. Whoops. And John's in charge of the mystery. He says, how far will it go in 7 hours? So now we use our same formula, but this time we use the K and the T that John gave us, and we're going to solve for D. So we can say D equals K is 15 times T is 7. And now all we have to do is multiply those together, and we will get the distance that our car will travel. I can do that in my head. It's 70 plus 35, and we're working in kilometers. I just got that out of the problem. I didn't have any special math skills to develop that. 105 kilometers is how far we'll go, traveling at that constant rate. Okay? Beautiful. Now, let's try another one that has more of a scientific story to it. It'll be just as easy. We'll pull the numbers, we'll solve for K, and then we'll solve for a mystery. Example 113, this will be point 1. The mass of a substance varies directly with the volume of the substance. Okay, I know kind of what mass and volume is, but not a lot, but it's okay, I don't need to. Mass is directly proportional. No, it says mass varies directly. As soon as we hear that, we know that it's A equals K times B, where K is the constant and A and B are the two scenarios, and we can change those to match our letters. So it says mass varies directly as the volume. So I put mass first and volume second. That's all there is to it. Now here's my step 1. I'm going to get the mass and the volume because I have to solve for K. So I know John's going to give it to me because he's a buddy and a pal. If the mass of 2 liters of the substance, okay, liters is a volume, so I know that's going to go here. If the mass of 2 liters of the substance is 10 kilograms. Mass is kind of like weight, so kilograms, that makes sense. Okay, so I use a little bit of logic to make sure I get the right unit in the right place. Then I plug in and solve for K. 10 equals K times 2. I want K by itself. I divide by 2, and I get K equals 5. Again, that's not a mass or a volume. It's just a magical number that connects the two. Not magical, but mathematically specific number that gets us where we want. Now, step 2, we look for the mystery. What will be the volume? I like to put a question mark in these. Of 35 kilograms And I know that's the mass because this was kilograms also. So I know that if it's kilograms, it must be the mass. What will be the volume of 35 kilograms mass of the substance? All right. So the only science you have to know is really not science at all. You just have to use logic to be like, okay, if I know that kilograms was the mass, then and they give me kilograms again, then that must also be the mass. Okay, now we use this and set it up. 35 equals K is 5 times V. I'll just use the same letter. We want V by itself, so I'll divide by 5. And we get V equals 7. And I'm going to look and see what the unit was. Volume is liters. Again, I don't know anything scientific about that being true, but I do know that when I look in the book and it says the mass of 2 liters is 10 kilograms, that tells me that liters is the volume unit. So I just look in the problem for whatever makes sense. Okay, and let's do one more of these before we switch to the other topic. This will be the third one. This is also science-y. Under certain conditions, the pressure of a gas varies directly as the temperature. Pressure varies directly as the temperature. I just take this formula and plug in my own story. Okay, scenario 1. When the pressure is 800 pascals, so that tells me that pascals are a unit for measuring pressure, the temperature is 400 kelvins. I know that because I've watched enough science fiction movies that I know they measure stuff in kelvins when it's super hot. Okay, now we'll use this and solve for K. 800 equals K times 400. We're isolating K, so we divide by 400, and we get K equals 2. Again, that has no meaning other than it's just the number that connects the two measurements. And now we say, what is the temperature? These temperatures are a mystery. When the pressure is 400 pascals. We use this same formula, so I put that in. 400 equals K times T. We don't know what T is. I didn't need parentheses. I don't know why I did that. Okay, remember that when we're solving equations, we look for the variable. Oh, I'm sorry, I did this wrong. We know what that is. It's 2. So there, I just put K equals 2. There's the 2. I usually put them in the other order, but that's okay. I see younger students getting confused at this point. They know that they have to divide 400 by 2, but they forget why. The reason why is because we're trying to isolate the T. T is being multiplied by 2. So we undo that so we can cancel. That's why we divide 400 by 2. Just dividing 400 by 2 is random and unhelpful. You have to understand why you're choosing to do that. So we get the temperature equals 200 kelvins is the measurement we used for the temperature. Yay! These are all right, by the way. I have not been using, this is my mark of a right answer. I know you have your own. I use the same color. That's because my mom doesn't have to check my work. Okay, now we're going to talk about inverse variations. Okay, for this one, remember we talked about toddlers coming into a room and taking the toys, and this is the number of toys that are thrown on the floor for each toddler, right? After 5 minutes. This variation is different. In this variation, we have dads coming into the room. And in this room, there's laid out a fabulous spread of pizza. Now, how many slices of pizza does the average dad eat? Maybe we should cross this out and make this teen boys. I think teen boys eat more pizza than dads, don't you? Okay, so I don't know. For every one boy that comes in the room, what do you say, like 8? Pizzas go down. 1, 2, 3, 4, 5, 6, 7. I didn't draw it long enough. Here, I'll draw it longer up there. Okay, and then a second boy comes in. 1, 2, 3, 4, 5, 6, 7, 8. Just enough. Okay, so this is called an inverse variation because the two different substances are moving in opposite direction, right? As each more teenage boy comes in the room, the pizza is disappearing. So as one goes up, the other goes down. With the toddlers and the toys, as one went up, the other went up, just not by the exact same amount. Okay? So that's what's going to happen in these problems, is that the things will be moving in opposite direction, and so our formula changes ever so slightly. Look what happens. We're still going to have this A and B scenario where we fill in with whatever makes sense to our problem, boys and pizza, for example. And we'll still have a constant, but this time instead of multiplying the constant times the second variable, we divide. That's where the inverseness affects the formula. So let's see. I think I have, how many of these? Just 2. Just 2. We're going to be done with this in no time. Then you're going to be looking for something more interesting to do. Oh, well, you'll have your homework, right? Let me just look if they're both science-y. They're both kind of science-y. Don't let it freak you out, all right? Again, it's just like before. Once we identify that it's the right kind and we know the formula, then we have the 2 steps. Under certain conditions, the pressure of a perfect gas varies inversely as the volume. Okay, so these are the magic words. Varies inversely. As soon as we hear that, we know it's this, right? And now we can change this to match our story. So let's look again at what it says. The pressure of a perfect gas varies inversely as the volume. So again, we just put them in order. Pressure varies inversely as the volume. Okay? Don't overthink that step. Students try to use their brain to logic that out. Just do it in order of the sentence. Okay, so now we have scenario 1, which just like before is where we're going to solve for K. And so we're going to get both the pressure and the volume given to us. When the pressure of a quantity of gas is 7 pascals, we heard that before, right? Pascals measures pressure. You'll kind of get an idea of these different scientific units and which one relates to which of the categories, right? Like pascals goes with pressure. And then when you see pascals, you'll be like, oh, I know that's pressure. And kelvins, we know, go with temperature. And liters is the volume again. We had that before. Liters measures volume. Okay, 7 pascals goes with 75 liters of volume. Okay. Well, we can do that, right? So now we're ready to solve for K. We're going to set it up like this. So it'll be 7 equals K over 75. All right. And then we cross multiply to solve, right? This is fine. I mean, you can look at it this way too. You can cross multiply, or you can say K is being divided by 75, so let's multiply it by 75. That works just fine, right? Okay, those cancel. 75 times 7, well, let's just do it. That's 35, 49, plus 3 more. So we get K equals 525. That's just a random number that relates pressure to volume. It doesn't have a unit or anything like that. It's just a calculation number. All right, and now we have our mystery coming up. What would be the volume if the pressure is increased to 15 pascals? All right. So I like to put the question mark because that makes it feel more mysterious. And you know, sometimes I like a good mystery. All right, so now we're going to use the same formula again to figure this out. P goes first. P equals 15. Now we know the value for K and we're going to divide it by V, right? So I used this formula, P equals 15, K equals 525, and then there's that. All right, now cross multiplying makes a lot more sense in this case, right? We can imagine this being over 1. So then we'll get 15V equals 525 times 1. I'm not even going to write that down. Now we can divide by 15 to isolate the V. Okay, 525 divided by 15. Let's see, that would be 3, which is 45. And 75, which we just figured out, is, well, let's see, that's not going to work out. That would be 2 15s make 30. 4 15s make 60, so it would be 5. Let's just make sure. 5 times 5 is 25. 2, 7. It works out. Okay, so what we get here is that our volume equals 35, and we already established from the other problem too that volume is measured in liters. Is that the right answer? Yay, we got the right answer. Okay. Oh, this was 4. And let's do one more. I hope these make you feel smart because it's all this chemistry, physicsy stuff going on. This one was chemistry. Now we're going to do one that's a little more physicsy. To travel a fixed distance, the rate is inversely proportional to the time required. The rate is inversely proportional to the time required. Once again, just put them in the order that you find them in the sentence, and that will always be your friend. Okay? 1. The rate. When the rate is 60 kph, the time required is 4 hours. All right, so we're going to use this. I'm going to skip down here so I have room to write under this puffy cloud. 60 equals k over 4, right? Just using this, plugging in. It's not very complicated, right? And so I get k equals 240. Multiplied both sides by 4. That cancels. There's my 240. All right. Now I have scenario 2. What would be the time required? Time is the mystery. Of the same distance if the rate were increased to 80 miles per hour. All right. We use this again. The rate is now up to 80 equals 240 divided by t. Okay? I'm going to cross multiply. That's over 1 if that helps you. 8t equals 240. Oh, I'm sorry. This should be 80, not 8. Make sense? So now we want to divide both sides by 80 so that we can isolate that t. And we get the time required to travel this distance at the new speed, the new rate, is 3 hours. I will say one thing for this lesson, you guys. John has been a buddy and a pal about making these numbers work out neat and clean. All right? So what you need to take away from this is that there are these things called direct variations and inverse variations, and they have a similar but significantly different formula, right? The inverse one has a denominator. The direct variation one, it's all in the top. It's a two-step process for both, in which we solve first for k, the constant, and then we use that information to plug in and solve for one of the mystery items. All right, I hope this makes sense. Like I said, next year we're going to take this and play with it a bunch more. So this is just a warm-up, and my only hope for you is that you'll understand it now so that next time next year, when we come back to these, you will look at this and go, oh yeah, I remember this. I don't remember it exactly, but it's pretty easy. That's my dream. And let's live that dream, shall we? Okay, bye.